Hello, this is Jeffrey Fox here again with another lesson uh, on the X-Informatics Big Data course. Here we're continuing our study of what we sometimes call lifestyle or e-commerce informatics, in particular on recommender systems. This lesson discusses one of the fundamental and actually rather simple algorithms, the k nearest neighbor algorithm. We, of course, remember the philosophy of this course. We're using clouds, running this algorithm, or more generally, data analytics. We do that collaboratively because that's what clouds enable. We process big data, and we solve problems in X-Informatics, whereas we noted X runs over lots and lots of different values, which are all, of course, displayed in our web clip art slides here. So in this lesson, we're going to introduce some Python um, code to describe an algorithm. This code is found online as part of a good book on machine learning called Machine Learning in Action by Peter Harrington by Manning. And that you'll find at this URL here. And we're going to go to chapter 2, and we'll use the software in this book with some minor enhancements. And in particular, those will allow us to change the format of one of the files, so use it in a three-dimensional plotting program. This section uses the following files which are available. There is the file from the book, dating test set 2.txt, which is a data set of 1,000 points, which will be classifying and using to produce recommendations. We have a little Python driver to convert that into the format used by the 3D plotter. We have two files corresponding to the results of this conversion. The doctext file is the raw file produced by the Python driver. The .pviz file is output from plotviz itself, and it has various formatting to make it look prettier. We have two Python files, knn, which essentially comes from the book, which implements the k nearest neighbor and various utilities, in particular the process files. And we have the driver file we're going to use in our IPython window to invoke these basic functions. This tutorial is built around two basically artificial examples. The first is particularly trivial. It only has four points. These points are in 2 dimensions, and they are already labeled. And they fall into pairs. Each pair is from obviously of 2 points, which are very close to each other. One essentially is 0, 0, and the other 1, 1 in 2 dimensions. Then we'll come on soon into an example with 1,000 three-dimensional labels. The case of the 2-dimensional labels is not read from a file, but just created in Python itself with the following Python code here, the create dataset function, which has a group command setting an array of these 4 2-dimensional vectors. You can see they're at x equals 1, y equals 1.1, x equals 1, y equals 1, x equals 0, y equals 0, x equals 0, y equals 0.1. And we label the points 1a and the points near 0, 0b. And that's a little function which is invoked and returns both the vectors in group and the labels in the array labels. Now we actually run some Python code, which is shown here. We will just do that, but let's go through this initial Python here. We, as always, set the correct directory where these files exist, and that will depend, of course, on your implementation. It's for me on the D disk in the directory python/recommender chapter 2. Then we have the import command for knn file. We set up a figure. This figure will actually have 3 subplots, as you'll soon see. The first command, which is invoking this create dataset function we already went through, defines group and labels. We're going to associate the points A at the top right with red and the points B at the bottom left as blue. And we define these colored group labels by having the values red and blue, which will be interpreted by the scatter command later on, right at the bottom of this page. So by the end of this page, as we define this data set of 4 points, and we've actually plotted those 4 points on a on the one particular subplot. Let's now go and actually run that Python. So to run the Python, we go to the file knn-driver.py. We copy it, and then we paste it into the IPython window. Hopefully there are no errors. No errors. And then we print, we do 2 returns. It thinks for a little while and then produces a result, which is shown here, which is the 3 plots, of which we just started to discuss the top plot, which actually we only discussed the 4 points, which are circles, 2 near 0, 0, and 2 near 1, 1. We'll go on to the other 3 x's in the next slide. And the 2 plots below we'll come on to later on. That's the 1,000 points, which we are sitting in a file waiting for us to read it.